As you can see from the title of the video, we're going to be talking about Terraform today, which is what we've got up on the screen. So just for context, previously we've been coding along to a Python Flask, but in this presentation we're going to be focusing more on DevOps. So the first thing we're going to do, we're going to talk about Terraform in this video, give you a few concepts of Terraform, which is where the context come in. So first thing we're going to do, we're going to talk about what is Terraform. I'm going to give you a little bit of a history of Terraform. We're going to talk about HashiCorp, the company that birthed Terraform. And then of course, no product is exactly perfect. So we're going to talk about just some of the few shortcomings of Terraform, and then look at some of the alternatives to Terraform, as there are alternatives to Terraform. And then talk about some of the scripts that you can run in Terraform. So I will show you just a small example of what Terraform script looks like. And then finally, we're going to dive into a few commands of Terraform, talk about some case studies of Terraform, so you can have an overall understanding of when you may use Terraform or why you will use Terraform and what it would look like. And that will conclude this presentation. And then in the next videos, we will talk more. We'll actually go ahead and write scripts. The first video will be kind of like a beginner script, just so you understand what your very first code to Terraform looks like, and how when you push it out to, or when you execute it, how it looks like and how it provisions these infrastructures. And then we'll do a middle video which will show you what kind of like a mid-level Terraform code looks like, and then finally we'll do it kind of a production worthy of what a Terraform code looks like. So yeah, we're going to get straight into this. So so let's get right into it. So the first thing we want to know is, what is Terraform? Now, in simple terms, Terraform is a use of a declarative code to allow for the abstraction of infrastructure configuration into archivables. And if you want to kind of move a step forward, you could also integrate Terraform with your version control to support your code. The written Terraform code will then drive the provisioning process into creating instantations of resources. So whether your resource would be a database, for example, or a server, or a network topology, or other resources, writing Terraform script or using Terraform will actually allow you to achieve this. So in kind of like very simple language, it's a tool that enables you to create infrastructures, configurations within any cloud vendor. And it's a script that allows you to actually drive the provisioning of these processes essentially. Now we'll talk a little bit about the history of Terraform, which is quite interesting the way it began. So it was co-founded by an individual named Michio Hashimoto, and the very first kind of release of Terraform came about in 2014, and at the time he only supported the AWS and DigitalOcean as the cloud vendors. But what was interesting was that in 2001 AWS actually released what was known as CloudFormation, which is an AWS alternative to Terraform. And so Mitchell actually wrote a Tumblr post in 2011. I should have actually included that Tumblr post in this presentation, but essentially he stated that if anyone could actually come up with a solution to create a CloudFormation version which would allow you to essentially provision resources across numerous cloud vendors. And of course, no one actually at the time came up with the challenge. And so in 2014, him and his team went back and wrote and released the very first version of Terraform, which at the time allowed you to provision resources within AWS and DigitalOcean only. So essentially it was to provide a cloud agnostic solution. But cut forward to 2021, there is a number of different cloud vendors that Terraform actually supports, which is extremely exciting. Now, just a little bit about the company, HashiCorp. It's essentially the company that gave birth to Terraform, and it was founded by two individuals. The first I've already mentioned, Michio Hashimoto, and the second being Armon Dagger. Now, apart from Terraform, they also do a number of other tools, which I will only talk about two. They provide tools which is DevOps in mind. So the first one being HashiCorp Vagrant, and then the second one being Packer. In later videos, I'll actually do a demonstration of how to use these tools, but just a little bit overhead. Vagrant is a tool for building and managing virtual machine environments within a single workflow, whilst Packer is an open source tool for creating identical machine images for multiple platforms, and you can do that from a single source configurations. Now, of course, with all software, Terraform not being one of them, there are some small shortcomings which I think is fair to address. They're not major; they're just very small shortcomings. The first thing being that Terraform hasn't got a simple entry. It's not a situation where you can actually get Terraform script together and then just execute it without having no background information. Hence, it has a demanding entry, and what that means is that essentially with Terraform, you're going to be provisioning resources being, which I spoke about in my other videos, in the AWS videos, which I will link below, but resources such as such as EC2 instances, for example, in AWS, or databases. In order to actually provision these resources, firstly, let's just forget about Terraform first of all. If you were to go into a cloud vendor, for example, GCP, AWS, and you wanted to set up a web application, for example, within there, you need to think about the fact that you need a database, you would need a virtual machine, so like a server. You potentially want to wrap all of these things in a virtual private cloud, and you want to think about IP addresses, whether that you will need a private IP address or whether you only need a public IP address. And then you also want to think about how your virtual machine and your database will be able to communicate with each other. That's a scenario whereby you don't. So in that scenario I'm describing, you have multiple servers essentially. Now, if you were going to automate the provisioning of these resources that we spoke about using Terraform, you need to understand how these things are going to interact and connect. So the first thing you need to think about is the virtual private cloud, the VPC. The fact that both the RDS and so both your database and your virtual machine or your server will need to be within the same virtual cloud in order for them to communicate. The same virtual private cloud in order for them to communicate. In AWS, of course, you also need to think about the subnet that these resources will reside in, and then of course you can go a step further and think about the different availability zones that they will exist in. And so with Terraform, you need to have an understanding of these things within a cloud before you can actually begin to write Terraform code. Else you can essentially be putting up infrastructures and not know where they are, for example, or what they're particularly doing, or how they're going to communicate with other resources. So that's one shortcoming of Terraform. It's not exactly. I personally wouldn't think it's a big shortcoming, just because of the fact that if you get to the point where when you get to the point where you're using Terraform, you would already kind of have an understanding of how to configure resources within these cloud vendors. And because of course a number of times is a manual process, and especially if you have a large number of resources to configure, Terraform would be an exceptional tool for you to automate that process. And what makes it even more exceptional is the fact that you can configure multiple resources within multiple cloud vendors in the same script, for example, which in my other videos I will show you an example of how it works. One of the other shortcomings is the fact that all in large, Terraform offers a free product. You can use it to freely provision your resources within cloud without paying anything. However, in the situation where you want to collaborate with other developers, especially if you're in a larger company, that's when you may have to look at the enterprise version of Terraform and actually look at the paid option. However, for most daily users, even within a company, you can actually get away with just using the free version of Terraform, which is exceptional. And then one of the other minor shortcomings is that it has no automatic rollback functions. That's not really much of a situation, especially when if you configure everything properly and you kind of write your script properly and you use the appropriate commands, you shouldn't really need to roll it back. But that's just one of the other small shortcomings. And then just a small information about the configuration files within Terraform. Firstly, it's written in HCL, which is the HashiCorp configuration language. And then, of course, most files within Terraform ends with .tf, which is mentioned here. So the .tf essentially, once you see once the .tf, it essentially tells Terraform that this is a file that I want you to look at, and this is a file that I want you to execute, essentially execute files from. Now, in terms of the alternatives to Terraform, the first one I've already mentioned, which is CloudFormation. CloudFormation is an alternative to Terraform, but it's an alternative which essentially you can only configure these infrastructures within AWS. So once you're using CloudFormation, you would have to understand that you firstly need an AWS account, and all the infrastructures you're using are specifically for AWS. So if you're going to launch an EC2, for example, using CloudFormation, that code would only work within AWS, which is where Terraform is such a great tool, because you can use the same syntax, the same kind of method of writing your script, and it will allow you to literally create and configure infrastructures within multiple cloud vendors. So it could be AWS, Azure, GCP, DigitalOcean, whichever is your choice. The second alternative is Ansible. I think I may have created a video on how you can actually no, I haven't. I'll create a video on how you use Ansible. It'll be part of the DevOps skills anyway. But you can use Ansible as an alternative to Terraform. It's not an exact alternative. Of course, Ansible has a completely different functions also. It allows you to kind of go ahead and talk to multiple servers once those have actually been created. Talk to those multiple servers and I guess give you instruction on what to do. So if you need certain updates running every so often, you can have that automated using Ansible. Kubernetes is a good alternative to Terraform, and of course Chef. All these listed 4 tools, there'll be upcoming videos on how to use those. They're great DevOps tools, and they'll kind of show you how important DevOps is within organizations, how it actually allows you to essentially speed up your release dates. This is what a simple Terraform script looks like. This is such a very basic script. So I'll just talk about it firstly. So the first thing you want to declare when you're writing scripts in Terraform is the provider, and here it will be AWS. If you were using Azure, you would put Azure in this particular section. This script will execute within AWS, hence why we have AWS here, and in that sense you will need to declare the region where you can declare the region where your resource will be provisioned in. So here it's EU West 1, which it's actually in Ireland, and then within the second section here is where you talk about your resources. The first this particular resource will be provisioned in an Elastic Beanstalk application. If you don't know what an Elastic Beanstalk application, within AWS, you can essentially create a microservice which will essentially set up, if you like, a cluster of instances which can run your applications, and it allows you to then quickly scale up or quickly scale down depending on the level of traffic or requests that you're receiving. So this bit gives instructions that you wanted to specifically set up an Elastic Beanstalk application in AWS, and that'll be the name of that application you're setting up, which is where you have the name here. Now, that's a very simple script. When you're creating these files, which I'll create another video of what the Terraform file should actually look like, and in that sense, you can actually configure certain elements of what availability zone it should be in, the VPC, the subnet. Else, if you don't actually state these things, it could result to the default version, which may work for your application. Maybe you don't actually need specific detailing. However, this is what a simple Terraform script actually looks like. And we'll talk about the basics command you need in Terraform. The first being once you've installed Terraform on your computer, whether that's a Linux I'm using a Windows using a Windows application. So I think the first video I'll do, I'll actually show you how to install Terraform on Windows, and then we'll go into Linux. Now, if you're using a Windows Windows computer, once you've installed it, it's a good idea to run Terraform -- version. This will inform you, and it will print out an output which will tell you what version of Terraform you're using. Most of the time, it should be the most updated, the most current version of Terraform, unless you want a specific version that you're using. And I think when you're installing, you can specify that. And then the second command that's quite useful, it's not just use it, it's a requirement. You Terraform init. What this does is that when you finish writing your Terraform script, you need to actually run this command first. And what it does is it allows Terraform to look into the script that you've written. Firstly, in the previous slide we spoke about, actually I'll bring that slide up. So when you run Terraform init, it will firstly look at that and say, okay, cool, we need to bring up the modules for AWS. If that had been Azure, for example, Terraform init will then say, okay, we need to utilize the modules for Azure or GCP or whichever. So you need to run that, and then once you've run that, also what you also do is it will also create a number of files within. So once you run Terraform init in your demonstration in the next video I'll do, you see that immediately another file will be created in the directory you're working in, and within this file, for example, it will have it will essentially so what that file does is that once you've run Terraform apply, for example, and you make changes to your script and you run Terraform apply again, what it does is it looks into those files that Terraform init has created, and it compares. It does a comparison and say, this is the resource that we've already configured, and the individual has gone ahead and made changes to the script, and so we want to compare and see what additional changes we may have to do. Maybe they want to go from a different size of an instance to another size of an instance of a AWS of a EC2 instance. If that's the case, then you can then Terraform init actually allows you to essentially make sure everything is in order, make sure that if there's any changes that it can do that. Terraform plan is advised, it's actually recommended you run that Terraform plan before you run Terraform apply. Terraform plan, it runs a dry script. It runs a dry provisioning of your resource. So it doesn't actually, once you run it, it doesn't actually go ahead and create those infrastructures in your cloud vendor. It goes ahead and just make sure the file makes sense, and make sure that the infrastructure that you're specified within your script makes sense and it actually works. And then lastly, Terraform apply, which once you run that script, you can go ahead into your cloud vendor, whether that's AWS, GCP, and you can see that if say you gave instructions for it to create an EC2 instance of like a T2.micro size, once you go into your instance version, you will see it initializing a script, initializing that virtual that server for you. Okay, now we're going to talk about the case studies. So these case studies are important, I think, especially when you're learning DevOps and you're learning Terraform. It's good to understand firstly why you would use it, because I've stated that if you want to kind of create your provisional resources in cloud vendors, that could not really mean anything to you. Before I actually dive into this particular case study, I'll give you a very small example of how you can actually use Terraform. So say, for example, you've started an online shop, and on Friday evenings you're going to get 50,000 people visiting your site, and you have one instance, you have one server which is going to take the weight of all these 50,000 individuals coming to your site. What you can do, what you can do is, for example, write a Terraform script instead of actually going into your cloud vendor, whether that's AWS or whichever you're using, and manually creating the settings for another resource or however many resources you need. You can go ahead and write a Terraform script, and once you've gone through the commands Terraform init, Terraform plan, and Terraform apply, it would actually respond and create those infrastructures for you. But in a much more bigger sense, and in the sense of a wider big company, a company called Cruise, which they create self-driving vehicles, so autonomous vehicles. They actually used Terraform on a much more successful level. And in this case, so Cruise is actually an autonomous vehicle technology company. Their sole aim is creating a world through technology where cars essentially drive themselves. And they plan to do this by building the world's best autonomous vehicle network to safely connect people to places and things that they actually care about. Now, they're the only self-driving company to operate an entire fleet to power vehicles with 100% renewable energy. And the infrastructure team at Cruise which was initially made up of one person, adopted Terraform open source as a method to kind of provision their cloud resources using HashiCorp configuration language. But when they created this, they were actually using a single repository. Hence, when their team increased to 800 software engineers and 40 SREs, they came across a number of issues. The first being in that they found it difficult to manage large mono repositories, and the second being that there was an increased risk of errors from a single developer's code that could impact others. And so by using Terraform to solve this issue, it allowed the larger team at Cruise to meet the increased size in their team by allowing them to quickly scale infrastructures in a sustainable manner through the use of Terraform enterprises. So essentially, when developers needed a server, for example, we could quickly meet that need by essentially executing one of the Terraform scripts in their repositories. It also allowed them to decompose mono repositories into separate, well-defined micro repositories, and then segment those usage and execute within their own workspace. So that's one of the ways in which Terraform was extremely successful for a company called Cruise. And then the next company, or the next case study we're going to talk about is another company called Pandora. Now, Pandora by trade is a leading music and podcast discovery platform, and they provide a highly specialized listening experience through their mobile apps. Now, with the quote which states that in our industry, it's imperative to roll out new services quickly whilst making sure the existing ones perform at peak efficiency. And this was said by Daniel, who is a principal system engineer at Pandora. This quote actually allows you to kind of see a little bit of why Terraform is so important. And in this quote itself, it's an indication as to why DevOps is so important within technology, and more importantly, why automation is more important. To address the objective that Daniel actually mentioned, from the quote you just read there, you have a problem. You either need to continually be hiring new developers for every new services that you're coming out, so that your current developers can take care of maintaining the existing ones, or you can keep your current size of developers if there's no need to increase and ramp up the level of automation in order to meet the demand of keeping the existing services at their peak efficiency. And for Pandora, they utilize Terraform to parse the manual task of allocating compute resources and network elements in order to drastically reduce performance issues and eliminate delays in rolling out features that their users would actually love. So I hope in this presentation you understood what Terraform is, where you can use it, just a small understanding of some of the commands that you have in Terraform and how they work, and of course finally how Terraform and how the whole thing works. I really hope you've learned from this kind of presentation. In the next video, I'm going to be essentially writing. So I'll release 3 videos. The first one will be a beginner's guide into writing a Terraform script, and it will just be a small file, a small script, which will show you how to implement a resource, an EC2 instance in the AWS. Second video will show you more of a mid-level, how to structure your files, how to use variables, how to use outputs from Terraform. And then finally, we'll create a third video, which will be a production-worthy, how to actually write production-worthy code for Terraform and how to execute that appropriately within your system. But yeah, thank you very much for watching this video. My name is Emmanuel, and I hope you've learned a little bit more about Terraform, and especially why it's so useful in the industry. Thank you very much for your time.